Hello coding friends. In this small coding example, I want to show you how to program a REST client with PHP. And for this purpose, we will use data from the organization NASA. Well, sounds a little bit spacey, right? To try the script by yourself, you need a web server with a PHP runtime. I use, for instance, XAMPP as a local web server. Well, as the title suggests, we want to use PHP to load data about Near Earth Asteroids from the corresponding NASA Webservice. And to get information about this web service, we have to go to NASA's API webpage. So let's switch to the browser's window. In the address bar of your browser, type in the address api.nasa.gov, hit enter, and there you go. If you want to use more features, you can get an API key here. If you now scroll down, we see an overview with the APIs that are provided by NASA. For our small and simple project, we use a Near Earth Object Web Service. So the query we will use in our script is this one here. Above you can see the parameters that are expected by the web service. We have a start date, an end date, and an API key. To see what we get back from the web service, we can send the query through a REST client. I use the Firefox plugin REST for this. So let's switch to the browser window to the REST client, paste in the query address, and set the HTTP method to GET. If we now click on the send button, the request will be executed and the result will be returned to the client. Response code 200, so the query was successful, and as you can see, the result was returned to our client in the JSON data format. This data can be easily processed in our program by decoding the JSON data into a PHP data structure. Good. Let's switch back to our code editor and start with our program. Since REST is based on the HTTP protocol, we need to program an HTTP client for our REST query. For this purpose, PHP provides the curl library as a solution. But first, you should test if you have the curl extension installed in your PHP environment. You can check this by using the PHP function. So we type the command php info. Don't forget to save it, of course. Then we change to a new browser tab where we can call our script. Hit the enter key, and as a result we get the information about our PHP environment. On this page we can now search for the term curl. In the search box we type in curl and voila! As we can see, curl is installed in this environment. We don't need PHP info anymore, so we can delete this command. Okay, before we start programming, let's take a closer look at the query. Just copy the URL into the editor and let's have a look at it. Let's make a comment out of this, so this will not interpret it as a command line. In the front part, we see the address and the path of the web service, and after the question mark are the parameters such as the start date in the format year, month, and day. Then we have the end date and the API key. For our simple example, we just use here demo key as an API key. With this standard key, we can query a period of 7 days. We will define this period dynamically, so the current day should be used at the end date, and then we calculate 7 days back for the start date. So we need to dynamically build our URL. First, we need to get our start date, so current date minus 7 days. For this purpose, we can use the date function. This function requires a date format. Remember, we need the format year, month, and day. Then, as the second parameter, we pass the timestamp for the date. Let's do a fast forward and simply paste in the necessary code snippet. You see here the format string for the date as the first parameter. For the needed timestamp, we get the current timestamp by the function time and subtract 7 days, given in seconds, from it. For the total numbers of seconds, we calculate 60 seconds times 60 minutes times 24 hours times 7 days. After that, we get the end date with the date function using the current default timestamp and set the API key to demo key. Now we need to put the individual parts together to create the correct query URL. The first part is the web address, followed by the parameters for start date, end date, and the API key. To test if the URL was built correctly, we can simply output the string using the echo command. Let's go into the browser window and reload our page. In the output, we now see our correctly built URL. Good. Back to the editor and delete the echo command. Now we come to the interesting part. We use curl to send the REST query to the NASA Webservice to get the data of the asteroids. First, we need to initialize curl. Here we get back a handle which we need for the following commands. And to keep it simple, I paste in the necessary curl commands as a whole. The first parameter is the curl handle. The second parameter is an array with various options. As the first option, we specify the previously built URL of the web service. There is a bunch of options you can specify here. So for more detailed information, you can have a look at the curl doc in the PHP documentation. Okay. If we have set the options, then we only need to execute the query using the curl exec function. And the response we get back, we just assign to the variable response. Let's first see if our query was successful and simply output the response with echo. Good. And now let's reload the browser window to run our REST query. Okay, it seems to work. The output is a bit confusing though, because of the floating text in HTML. But we can improve this by putting the HTML pre-tag before of the echo command. We echo out the pre-tag, switch back to the browser, hit reload, and now we see a better output of the response data. As you can see, the response is divided into the header part and the body part with the actual data in JSON format. We can delete this test output. As the next step, we want to split the response into a header and a body part. Thus, we can extract the JSON data. Unfortunately, curl does not have its own function for this purpose. Therefore, we need to get the size of the header and use the substring function to cut out the individual parts. The body part we print out after the pre-tag. Again, reload the page, and now we got only the JSON payload. To better work with the data, we will convert this JSON data into a PHP data structure. For this, we will use the JSON decode function. By using true, the JSON code is stored as an associative array in the variable a NASA data. To view this complex data structure, we print out the contents of the variable using the printr function. So let's see what we get. Switch to the browser, reload, and now we can see the data in form of an associative array in PHP. And what we see here is a complex, multiple nested array. But the interesting part for us is this one. Underneath this subarray, there is the data on the Near Earth objects that we want to process. The data on asteroids are listed by the days of the closest approach to Earth. The days here are used as array keys. With one day, more than one object can fly by the Earth. Therefore, these objects are represented as a numerical array. The actual record contained the fields with the data for the particular asteroid. For instance, the name or the estimated diameter. For instance, given in meters. Okay, Let's go back to work and comment this code out. What we need now are two nested loops. The outer loop to go through the days and an inner loop for the corresponding objects on that day. For the loops through the days, we use a for each loop. Remember, all the data we need lies underneath the field Near Earth object. So we simply copy this key and paste it in here as an array key. At each iteration, the current key is stored in $key and the value in $a day. The variable a day again contains the numeric array with the corresponding object data. And remember, the variable $key contains the date with the closest approach to the Earth. So we will output this date as the header. Good. Let's return to the browser, open a new tab, and here we reload the script. Well, as we can see, all dates are now printed out one by one from the oldest to the newest. Okay, now let's build the inner loop for the actual object data. At first, we want to output the name of the asteroid, and to do this we set the array key for the asteroid name in the current object record according to the key in the given data structure. The key is called name, so we enter this as a key in our array. Let's reload the website. Now the names of the asteroids are displayed. To improve the readability, let's increase the line spacing a bit by putting the data about the asteroids inside paragraph tags. Let's see how it looks now. Okay, it looks clearer now. Let's go ahead and next print out the diameter of the asteroid. Again, we have a look at the data structure, and for this purpose we search for the element estimated diameter. As a unit of measurement, we have chosen meters here. We print out the minimum and maximum values, followed by the BR tag for a line break. Then reload the web page and the diameters will be displayed. Then we want to get rid of the fractional digits, and to do that we simply can use typecasting to convert the value to an integer. Let's type in the unit meter, reload the web page, and now we see the diameters as integer values without the fractional part. As the next step, we output whether the asteroid is potentially dangerous. This is specified in the data structure in the field is potentially hazardous asteroid. If it is dangerous, the flag is set to 1. First, we print out the text potentially dangerous, and in the next line we use the ternary operator to check the flag in the field. If the value is 1, then the text yes will be printed out, otherwise the text no. Let's see it in the browser. If the flag is set to 1, a yes will be displayed at this point. Now let's output the data about the approach to the Earth. These are located under the element close approach data. Here we have a numeric subarray with only one element, so we set the index to null here. Let's take the time of the closest proximity to the Earth. Let's paste in the line and see how to access the data. We have the element close approach data, then index null, and then the field close approach date full, which contains the time. Let's write the next line as well and output the relative velocity here. Go to the browser window, hit reload, and yes, here we go. As last information, we want to show the distance which the asteroid misses the Earth. In the data structure, this is given in the field missed distance, and as the unit, we choose kilometer. So enter the text missed distance followed by the data. Let's watch that in the browser as well. Finally, we want to improve the number formatting. Here we also want to get rid of the fractional digits and insert thousand separators. This job is done by the number format function. Okay, maybe we should allow one fractional digit after the decimal point. Okay, copy this stuff, paste it in the next line and do the same here. And yeah, here we go. Reload the web page and we see the numbers are now formatted with a thousand separator and have one fractional digit. In our example, we are slowly heading towards the end. But there's one point we want to improve. We will set the font to Courier to get a nicer and more consistent text output. Well, then let's look at the final result of our work. Now the output looks better structured. Of course, you can also output the data, for instance in an HTML table, or process it however you like. Okay, thank you for watching this video and I hope you enjoyed it.